All right, problem number 15. Woohoo! Okay, a 15 kilogram box is, oh my gosh, where's my pencil? Pulled as shown. What force of friction will keep the block at rest? And I say show using a free body diagram and equations. Whenever I say things like that, students are like, oh my God, what equation? You didn't give us equation. And please don't panic when you read phrasing like this. All it means is do the thing that you've done like a million times before with me. So our free body diagram, we've got a normal force. We've got the weight pointing down, or the force of gravity, whatever you want to call it. Now we have this F1. I'm just going to call it F1, okay? And I'm even going to label it 20 newtons, all right? Now here's the thing. If I'm pushing to the right, I need a force to the left to balance. And so when I set up my equations, vertically they balance because the block doesn't fly up into the air. So I have Fn balances Fg. You can write it like this. I want honors. I want G period to write it like this, and F period you can write it like this. Okay, so either one's fine. Either one of these is okay. And then horizontally we have F1 minus the friction force equals 0, or if you're in F period, you can just write F1 equals F. Now here's the deal. I've got this 20 Newton force fighting the friction, and the effect is that they balance, which is why it equals 0. And so we're simply going to get a friction force of 20 newtons. All right. Now, oh my goodness, F2 pulls at 30 newtons, but now we have this friction force acting. And I should have been clear, and this is now someone else. So the idea is that we still have this friction force going to the left. So let's be careful with this. And I'll specify that more carefully when I actually give you your exam. So what I want to say is I've got F1 here equal to 20, and I have this F2 equal to 30, and then I have this 20 Newton force acting to the left. So let's set up our horizontal equation. Now we're no longer balanced, so we have F1 plus F2 minus 20 minus the friction force. But since it's not balanced, that equals ma. So we're going to have 20 plus 30 minus 20 equals 15 times a. This gives us 30 equals 15 times a. So that's 30 equals 15a. And we're going to divide both sides by 15. And we're getting that a is 2 meters per second squared. That's our acceleration. All right. Now we cut both ropes. What happens to the motion of the box? Let's just see. So we've got the normal force, and we've got the weight, or the gravity force, and we have this friction force going to the left. And what's going to happen is the block will slow down and stop. All right, it's pretty exciting pulling blocks and watching them move. Okay, so that's question number 15, and I'll put this on availability. That didn't make sense. All right, I'm just going to stop talking now.